Okay, everybody, we're going to get started. So first, I'd like to thank all of you for coming and joining us tonight. We're really excited to have you here. We're really excited for our talks. And I also want to give a really big thank you to Zymergen for hosting us. This is a lovely space, so thank you so much. And I'm going to kick it off to Courtney for a few words from Zymergen.
Hey everybody, I'm Courtney Shear and I'm a data scientist here at Zymergen, and I forgot my clicker, so I don't know how I'm going to flip through the slides. And to get started, I just want to go through some logistics with everyone. If you have to use the bathroom at any point during the talks, it's right through those doors. There's some nice signage there to direct you. And in the case of emergency, if there's a fire or something, if you turn to the right, go down the hall, find the fire exits. And I'm going to give a quick recap of tonight's schedule. We're a little bit behind, but it doesn't really matter. And registration networking, we're going to have two awesome lightning talks and a main talk. Then we're going to have a question and answer section. And then we'll be finishing up slightly after 8 o'clock and appreciate your play. Once we're done, just make your way out so we can clean up and get going. All right. So Zymergen. Zymergen is a science and material innovation company. Our vision is to be a catalyst for a new industrial revolution that creates a vibrant, sustainable future through biology. We're founded in 2013. We currently have over 800 employees. Our main headquarters is in Enrico, California, which is where I work usually. We have additional offices in Seattle and in Boise. There are many career opportunities at Zymergen amongst diverse teams from bioinformatics, chemistry, data science, what have you, and software engineering. We should ask about that. So at Zymergen, our goal is to build a company that brings products to market that leverages the inherent advantages of biological chemistries. Now, biology is really cool because it promises a wide range of products that are both innovative and great for people and the planet. Biology offers unique solutions through diverse chemistries, natural alternatives, and fewer externalities than petroleum. But biology presents some real challenges. Discovery is expensive, commercialization is uncertain, and cost is high. So, Zymergen has transformed biology into a tractable molecular technology with data and algorithms. It's where that data science can come into play, right? So we start with searchable diversity to design the right cellular system. This allows us to make discovery predictable and cost-effective, because now we have data that is searchable, addressable, and we have a local library of biodiversity. We also have algorithms that we can use to connect sequence and function to enable effective designs. And then we use robotics and data science to optimize this entire system. So this allows us to pursue strain optimization predictably as data science exercises require machine learning to empirically drive optimization through iterative search and consolidation, large volumes of robotically built variations, and precise biological estimates. So, thank you all for coming to Zymergen today to join us. If you have any more questions about what Zymergen does, please reach out to the ladies on the screen who are here tonight. We have a diverse array of individuals, but we all have a common goal of using data science to make really cool biological discoveries. And there's many more data science ladies in Emeryville. I'm one of them, but we have much more than 4. So, and with that, I'm going to hand it over to Elise.
Thank you so much. Okay, thank you. So my name is Elise. I am the volunteer coordinator for Seattle Women in Data Science. And if you've never heard of us, we are we're a supportive community focused on spreading knowledge about data science. We are welcoming to everybody, but we like to
focus on highlighting women. Our speakers in leadership are all women, and we focus on professional development, knowledge sharing, and mentorship. Follow us on social media. If you're not a part of our Slack channel, we have a very active Slack channel. And in order to join, you need to go to our meetup page and fill out a Google form. Once you fill that out, someone will accept you and add you. If you have more questions about that, come up and see me after this event. So I want to talk about a few of our upcoming events. Our December technical talk with Billing Project with Jacqueline from Team Mobile. I think the date for that is December 5th. It's not on our meetup page, but it's not on our meetup page yet, but keep a lookout for that. Our January technical talks, we don't have a date, but it's going to be at Fred Hutch. And we're going to be, it's going to be at Fred Hutch with some data scientists from Fred Hutch. We have some upcoming events next week. On Monday, we have week 5 of our Women Intensive Flow series. On Tuesday, we have our weekly deep learning book club, and on Wednesday, we have, Tuesday is our deep learning study group, and Wednesday is our deep learning book club. Check out our meetup page if you want more information about those events. And finally, our annual conference has been set to be April 2nd of next year. Put it on your calendars. We want to see all of you there. We are actively recruiting for a few positions. The first one is a social media coordinator. We have Twitter, Instagram, Facebook, LinkedIn, but we need someone who can help coordinate, help generate posts, help coordinate all of our social media efforts. If you are interested in this, please email seawids.volunteer.lead@gmail.com. It will be a bit of a higher time commitment, but it's a super big need, and we are really looking to grow these efforts right now. We're also looking for some coordinators to revive our interview prep group. We used to have a prep group that would practice for data science interviews. The coordinators were all too busy to continue doing it, but this is a need that we hear a lot from our group members, that people would want help from. So if you're interested in reviving this group, please come talk to me. I will definitely give you a lot of help with coming up with content and how to coordinate study groups and stuff like that. And the last one, we just found someone. So also, if you don't have the time to fill these roles, these are a little bit more time consuming than normal volunteering. We are looking for general volunteers who would be available for ad hoc events. Like we could just send an email out like, hey, we need someone to help check people in at this event. Are you available this night? Lesser time commitments, but we're trying to build up our list of volunteers. So again, if you are interested in any of these roles or just want to get more involved with this group, please email me or message me outside. And that's all I have. And I think we're ready for our first lightning talk.
I should use the microphone, right? Can you hear me okay?
It's a little awkward for me tonight.
Hi, my name is Mia Eisman. I want to say thank you. I want to say thank you for reminding me to get the clicker, and thank you for having me tonight. I was planning on putting the light in lightning talk to keep it kind of fun, and I'm going to present to you a project that's a passion project of mine, and the reason I mentioned keeping it light, keeping it fun, is because that was the motivation behind this project. It's a game, so I'll tell you about why I created it and what I hope to do with it in the future. I will play the game. I was thinking through what I might want to do for a project that focuses on using data science, and specifically, I was interested in NLP. And when I was thinking through things that are just fun for me, I thought, actually, I have a lot of hobbies, and I kind of wanted to mix them together. So I don't know about for you guys, do you like board games? Like board games, yeah, see some hands. So I like board games. I like doing things with a team where it's not super competitive. Like, has anyone ever done an escape room? Yes. Other nerds out there, okay? So I
I really like escape rooms, and I designed a few of them even, so super nerd. And then, does anybody do improv comedy? Yes. Few people have ever been to an improv show. They're fun, and so what I did was I decided to, I just thought, well, not everybody has these same hobbies or the same group of hobbies. Puzzle hunts are another one. Do you guys do puzzle hunts? Maybe nobody for that one. It's like an extended brain teaser competition. They're super fun. Microsoft does a whole weekend where it's like a 48-hour one. It's kind of like a treasure hunt, but you have to use your brain a lot. So anyway, I thought, not everybody's heard of some of these things or these games that I really like. How could I share them and utilize data science? And so what I did was I took an improv game called Convergence. Has anyone ever played it? It's also called Mind Meld, and it's where you try and get on the same page as someone and kind of get inside of their mind and take their perspective. And so philosophically, I like this game because there's a lot of divisive talk in the world, and this is something that is supposed to bring you together, and it's not me versus you, it's us trying to win the game together, so it's cooperative. This is how you play. So I just made up a little example. Two people, there's lots of different ways to play, but the most common way is two people are talking, I'm sorry, they're not talking, you pause if you're talking, and you just think of a random word. So she thought of apple, he thought of wall. And then you think, what's the convergence of those two words, the ideas behind them? Have you played this game before? Yeah. So it's really fun to play with a group of people or even just one other person. It's a great road trip game. What you would do is, the next round, you say them at the same time so you're not influencing each other. So she said the convergence of, does it work to go back? Perfect, thanks. Apple and wall were their two random words, and they said, she thought it would be tree, and he thought skin. And so maybe you guys would think something else. The next thing that they think of happens to be park, and that's a convergence, and they win. It doesn't always happen after 3 rounds, sometimes it doesn't happen at all, sometimes it takes 40 rounds. Just so you understand it, and because this is a fun networking kind of event too, why don't you just turn to somebody near you and try and play a couple rounds. So it's like 3, 2, 1, and you just say a random word. Yeah, and actually Gina was going around handing out these cards. Here's mine. So if you don't want to think of a random word, you can play it with the play. So just take a minute to do that and see how it goes. Okay, do one more round. Look up here with your all right. I think because everyone's still talking and it worked. Some of you converged. Some people are still trying to. I'm sorry. Did you think it was fun by a show of hands? The people that converged are like, yeah, it's fun. Okay, so if you do think it's fun, if you want to teach someone how to play, if you're bored on the bus, what I did was I really liked that game, and I thought this lends itself to natural language processing, and so I made a bot that you can play with or against, depending on how you think. So it's at playconvergence.com. I was just going to show it to you all, but feel free to go on your device as well. Sorry. That will work. Okay, so the way that the bot works, so I said apple and it said agricultural, and so when you think of the convergence of those things, you might go bigger or smaller. Ooh, okay, that was awesome because I didn't know. I've done this presentation once before and it did not converge, sadly, so that's great. So I chose to kind of go bigger, but you probably noticed that when you're playing, you're like getting closer, but then you're getting further away. So it's just part of the fun. So I'm going to just tell you how the bot works. And I'm not sure of the technical level of the folks in the room, and so I'll know by your questions, and you can feel free to just ask questions immediately. You don't have to wait till the end or anything if you want me to go into more detail. But I was just going to give a high-level overview. It interprets the words as vectors. I had found a group of word vectors already online, and so it's actually using 2014 Wikipedia articles and Google News articles from a data set called GigaWords. So I'll talk more later about things that I think would improve the design of it, but it is related to the source material. And then it basically takes, it interprets the words as vectors, and then it averages them using cosine similarity, and it returns a common word. So additionally, I thought this, I don't know if we need this part. It seems like most people in the room are tracking what I'm saying, but this was just an example of how the word vectors work. If it were two-dimensional, you could think of the dimensions, for instance, as like religionness and familyness, and for sister and brother, you might say that the convergence of those two vectors is the word father because it's the average. However, the bot takes in 400,000 words, and I think if you look online, there's less than 200,000 words in the English language, and so it's including proper nouns and abbreviations and things like that, totally made up words that appear in Wikipedia or Google News. And so there's 300 dimensions per word, and the way that I figured, the bot needs to converge at some point or the game is not fun, and so it needs to mimic how a human would think. So I limited its responses to the 10,000 most commonly used English words. I did a little bit of not very technical research, just what I could find for free online about how many words we use each day as the average English speaker, whatever that means. And so 8,000 seems to be a sweet spot where you can converge usually with the bot with less than like 40 words, and oftentimes a lot less than that. I don't have a way of measuring the success of the model, so I just put in my anecdotal feedback that I got. It's been really fun to introduce it to some of the communities of people, like some of the improv comedians had really funny responses because this is a game they play all the time, and other people are like, wow, I never knew this existed, this is fun, like that middle person. I also had some friends tell me that, one friend told me she was pregnant by playing the game, and just sent me this screenshot, that was her announcement, which I thought was pretty funny. And then more interestingly, I had someone converge on the first one. And he texted me this screenshot and said, I think I broke it. I don't know what the actual probability is. I keep meaning to figure that out, but it's 8,000 different options for the robot to say, and I don't know what the options are for that particular friend of mine, but probably higher than 8,000. So when I think about where it could go in the future, the reason I say practically limitless, which sounds very markety. But it's because so many things these days are brandable. So like if you wanted to have a Harry Potter interactive web app where you are casting a spell, I'm just making this up. I don't know exactly what you would do with it, but you could have the vocabulary be that of the Harry Potter universe and the characters and the movies and everything. So the branding side of it is really cool to think about. But what I'm actually more interested in is, I keep forgetting about the clicker, is I have a Spanish version of the web app, just because I happen to speak Spanish, but I would love to have other languages and actually pitch it to Duolingo as an app that could help increase your vocabulary and sort of gamify the educational experience. What I picture, which I don't have up here, but visualize it with me, is I picture you playing in your non-native language, but having an option to click on a word if you don't understand it and see the definition in your native language, because you're playing a game, so you're automatically more invested in what you're doing. So that's an idea that I'm really excited about. Admittedly, a little less excited about the Alexa skill because, like I said, the motivation behind it was for it to be fun and for you to potentially introduce it to your friends as a game that you can play together as humans. So the bot playing isn't really the end goal. That's why I'm more excited about an educational experience. Playing with Alexa is less fun than playing with your friend, but I still think of it as an option. And then I also think it would be a really fun experiment if I ever got the time to train it on a different vocabulary and have it play against another bot. So one that's trained on Twitter vocabulary, some tweets, and then one that's trained on research papers, and just see if they could ever converge. And that would be a really cool experiment for today's political climate as well, or just any two parties that consistently disagree. I think it would be really cool to say, look at your vocabulary, there is a possibility of convergence. So those are just some ideas. And I think that's it. I threw a puzzle in this one. I threw a puzzle in the first slide. I don't know if you guys saw it, but I threw a little puzzle in this one too, because if you want any more information, or I am currently seeking a job. So if you want to talk to me about anything within Seattle's tech world, I would love to hear about it because I'm somewhat new to Seattle. And so if you have a company in mind or any suggestions for me, totally open to that. And with that, if you have any questions about the bot or if I can go into more detail, I'd love to do that as well.
What did you use for your website graphics interface?
So I used a Flask app, and I had help with it because I found Flask to be difficult to learn. It was an experience making it. Most of my time was spent on deployment. But I used a Bootstrap website for the template of the HTML and CSS. But I went in there and changed all the graphics and the fonts and stuff. So it was some templates, but some hard work in there too. Because I don't have a background in HTML or CSS. Yes.
Do you have a sense of kind of the gameplay of the bot versus a human gameplay? Like, is it something that you can actually tell?
I can tell because I used lemmatization in the word choice, and it didn't work as well as I wanted. Raise your hand if you've used lemmatization so only a few people have, so I'll go into a little more detail because I think it's really interesting. For instance, the bot, if you say play, the bot might respond with plays, whereas a human would think, we're done with the word play. I'm not going to say plays. A lot of people say that's cheating when they play with it because humans do not think like that. They're ready to move on to the next one. The lemmatization is interesting and did not work as well as I wanted with the bot because it thinks of plays and play. I think it thinks of play as the noun or the verb, and then plays could be a noun or a verb. And so for some reason, it doesn't get rid of plurals all the time. For instance, nurse and nursing are two totally different things to the bot, I've noticed. It also just depends how the vectors are situated within that group of words. So, but yes, I definitely noticed, and I noticed that if you type mom, it will always say dad and vice versa. So that was my backup plan tonight. It didn't convert. And then dad, I convert. Luckily, we got it in 2. Any other questions? Okay, thank you.
Good evening, one and all. I'm Dr. Vijaya from India. I've been working there in an institute as a chair of a department. Recently, I resigned my job. My daughter is doing her PhD here in Seattle. I thought I'd be here with her for some time. And I started attending the TensorFlow workshop series that is being conducted by women in data science. And that's where I got to know about this. I thought I would be talking a little bit about my machine learning research, which I did way in 2000s. So before I talk about my work, I thought I would give a little bit brief history about what machine language is when it was then, before deep learning became prominent as it is today. Here in 1950s, the first learning machine was developed by Turing, which was followed by a neural network machine, which was made for, which used stochastic, which is used as a calculator and used the concept of stochastic modeling. And subsequently, they came up with perceptron, which is an algorithm and which is the basis on which we have MLPs being used in 90s. And subsequently, it turned out to be the basis for the neural networks and the convolutional neural networks which are being used nowadays. Here, earlier to 1950s, we had Bayesian theorem and least square method that were introduced by researchers at that time. This Bayesian theorem has formed the basis for Bayes networks that are being used in machine learning. And least square method is the one which is currently being used for doing data fitting. And when moving on to 1960s, the Bayes theorem, based on the Bayes theorem, the Bayes method has been formed during 1960s, which was followed by the nearest neighbor algorithm that also was used in machine learning. And automatic differentiation was introduced in the year 1970s, which is a basis which is meant for the current day backpropagation algorithm. And neocognitron is supposed to be the first artificial neural network algorithm that has been proposed in 1970s, which was used for performing machine learning. Coming to 1980s, we had the backpropagation algorithm, which is a modified version of the neocognitron that was used. And they came up with the Q-learning algorithm also during this. And I'm talking about all the researchers who have come up with new methods that has come into existence in the machine learning domain. And Q-learning was introduced, which also helped in coming up with improvised version of the neural network. And the first neural network-based program was released in 1980s. And basically, those programs were meant for playing games. So I hope the previous speech was very interesting. I'm not sure whether I will be able to speak to her extent, but I'm here just to share my experience and tell you all how we have come to today's machine learning. And in 1990s, there were a lot of works that has been happening by using support vector machine. And the variations of the neural networks were introduced during that time. And the main thing here is there was a shift in the approach in which the learning was happening. So earlier to that, they were more focused on knowledge-based learning. So in the 90s, the shift has come towards data-based learning, as we see it today. And in 1998, the first, MNIST dataset has been released, which is meant for character recognition, and still it is being used as the benchmark dataset for performing character recognition. machine learning algorithms. And in 2000s, around 2000 is when I did my ML research, basically for clinical diagnosis. And during that time, many unsupervised learning methods have been introduced, and we had the first ML library, which was given as an open source. It is named as Torch. And ImageNet dataset also was brought out in 2002. And in 2010, the Kaggle platform, which is very well known, all of you must be aware of, it's a platform which is used for conducting machine learning competitions as of now. And deep learning also came into existence in parallel along with Kaggle in 2010. Though deep learning was being used earlier, it became more prominent in 2010s. So I just thought I would share the type of research that I had done during my PhD. And here I used two data sets. The data sets, namely hepatitis data set and heart disease data set, both of which I had taken from UCI repository, which is supposed to be one of the benchmark data sets, and was researched more in 2000s when I was also parallelly doing my research. So I had just given a gist of the results that I had achieved when I was doing my research. So basically, most of the networks that were used were based on multi-layer perceptron around that time. So here, multi-layer perceptron with back propagation was mainly introduced around that time. And I also had worked on that. Apart from here, feed-forward neural network is the one which we worked on. We also worked on a decision tree algorithm. We looked into venturing for neurofuzzy algorithm, like getting into fuzzifying the input data and then using the neural network to predict. So as far as hepatitis data set is concerned, we have used the models that we developed two models, as you can see here. So we have used them to predict whether the patient would be able to survive the disease or not. And we were able to get the accuracy which were at par with most of the research that was happening at that time. And coming to the second data set, it is the heart disease data set. And here again, we worked on having 5 classes which talks about the different level of severity of the heart disease data. And not many researchers were working for classifying into 5 levels of severity. And the ones which was available at that time had 72% as their accuracy rate. We were able to use the genetic concepts also being introduced into the model that we had developed, and we were able to achieve 88% of accuracy. So we thought, like, after doing this, we should be able to use our local data and check whether it is working for our patients who are local to our state where we were. But at that time, doctors were not receptive of the researchers approaching them to get the data. And we were not able to get actual data from our locality. So I could not validate our model as to how it works for the real patients who were there in our locality. But what is that we did is, subsequently, we thought like we would be approaching some doctors and get the data, but at least till quite some time I was not able to achieve it. And I had collated all my data regarding my research and I was able to get my PhD, following which I was given the position of chairing my department. And I think you all understand, like, once you are chairing the department, you would not be able to focus much on the research that has been an interesting aspect for you. So I was not able to pursue that parallelly. And that is one of the major reasons as to why I thought, okay, after 8 years, I'm not able to continue what was interesting for me when I started doing my PhD. So I thought I would take a break from my teaching career, and then I would think as to how I can start doing my research in a way that would be useful for my community. Because a couple of friends of my husband, who is a doctor by himself, so they are orthopedic surgeons. So they were discussing with me and they were discussing about their ideas as to whether anything could be done to get a system that would help them to predict the status of a patient well in advance. So I thought like, why can't I start looking into, since there is a gap. After finishing my PhD, I was not pursuing my research that much. So much has happened in between. So I thought, having come here, I will attend the TensorFlow workshop series. And now I have a better idea as to how things are happening now. And I'm sure that once I return back to India, I would be able to discuss with my husband's colleagues and get the data, because nowadays they are storing the data. We need not have to go and approach the hospital. Doctors themselves are able to store the data. They are interested in doing some research on the data which they have collected on their patients. So I think I should be able to go and start working on that again. And I hope I will be able to contribute better to find if the machine learning models that we will be developing subsequently will help the medical practitioners to do better, because the number of doctors who are available in India is way too less when compared to the number of people who are suffering there. So I hope I was able to tell something which would have been of any use to you all. The main takeaway I would expect you all to do is, if you are interested in learning, you can do whatever you want. Thank you.
Any questions?
I hope at least I was able to give some insight into it. I was not over your head. Because sometimes we get a doubt when our students are not responding. We have a doubt as to whether I was able to reach them or I went over their head.
My only hesitation with not asking sooner was that I can probably Google it, but if you know off the top of your head, when you showed the history, you mentioned that it was used for playing games, but were any of those early advancements used in products that people used back then? Like in the 70s, did they create products out of any of
Not
that?
in 70s, at least as far as what I could look into. In 70s, they were not having any products coming up.
When do you think the first product came to market that used it?
In 90s,
Yeah.
80s, 90s.
70s was cash cards.
Late 80s and 90s.
I mean, the end of it, but,
Well, they were using tape too.
yeah. I know. Yeah, that's why I was kind of curious about, like, the processing power and how that became more available.
Yeah,
Compared to this.
that is basically when I was doing my research. So let me tell you, if I wanted to test my model with a set of even 600, 700 data, sometimes when I run it, it took around 4 hours or 5 hours to give me the result, which I'm sure now you will be able to get in 5 minutes.
I think our question was more around, like, usually there's something driving these advancements, so, like, what were things driving these methods? Like what research was actually driving these methods to be developed?
Which
Like
research?
the applications, whether business applications or.
So for instance, in 1960s,
Yes.
did someone just invent nearest neighbor algorithm, or was it because they were trying to solve a problem and
No, they invented an algorithm which worked based on the nearest, for classifying based on the nearest neighbor method. That was research.
What programming language did you use in your research?
For my research, data lab, MATLAB was the one which I used at that. So now I'm working on Python and it's. So Python, recently I learned Python because I had to handle for my undergrads. Because in fact, when I did my undergrad, I finished in 1990. So we had only C to be there in our final year, and whatever we basic, Fortran, Pascal, those were the programming languages which we had during our undergrad. But by the time I came out of the college, none of them were there. Because they were being used as only in the legacy systems. Of course, COBOL, I worked in industry for a couple of years. So I was working on COBOL programming language. So that was the only use of what I did during my undergrad. And now I think it is even more, the rate at which the technology is changing is even more fast than compared to the rate at which it was happening. Now, I don't know, that's what I keep telling my students. So you have to keep learning. You can never say like, once I'm done, okay, I go and work and you not have to learn anything new. That's not the case now. So even 6 months is too long a period for a technology to be sustaining. That is what we see nowadays. Yes.
I am super stoked to be here tonight, and I'm very excited to talk to you about some of the work my team and I have done at Nordstrom around anomaly detection, specifically for fraud at Nordstrom. And the two packages that I used in this were HDBScan and isolation force. And so I'll be describing the differences between the two methods and talk about some issues with putting these methods into production. So let's start by just talking about anomaly detection. Anomaly detection is the identification of rare items, events, or observations that differ significantly from the majority of the data. Anomaly detection can be applied to a number of different fields. And it could be used in event detection, system health monitoring, in engineering. It could be used to monitor structural defects, such as in roads or bridges or dams. In the medical field, you could use it to detect medical health problems, such as cancer. The field that I'm interested in, however, is its use in fraud detection. And that, oops, okay. And so that is the area that I'm going to focus on tonight. And I work for Nordstrom, so I'm going to specifically be thinking about retail fraud. And I have some examples of retail fraud up here, but I don't recommend that any of you actually use these examples. So the first example that I have up here is renting or wardrobing. This is when somebody actually buys an item for short-term use and then returns it. So an example of this type of fraud would be somebody buying a TV for a Super Bowl party and then returning the TV after the party. The next one is shoplifting with a receipt. In this example, somebody would go in the store and purchase an item and get a receipt, and then later return to the store, pick out an identical item, and then return it for cash. Another example is when somebody would find a receipt and go into the store and pick out all of the items on the receipt, and then return them for cash. And then the final example that I have here is fraud committed with no package received claims. These are claims where a person buys a package online, they receive the item, but then contact the retailer and tell them they did not receive the item so they could get a refund. This is the type of fraud that my team and I had investigated. And so this is what I'll be talking about for the remainder of the talk. Okay, so let's talk about what happens when you order an item online. First thing that happens is that your items are picked and packaged by an employee. Then once that package is put together, it's given to some shipping company, so that way they can deliver it to whatever address you have given them. And then the final step is it's delivered to your door or some other facility. But most of the times it's actually delivered to an insecure place like your doorstep. If everything goes well, at the end of this process, we have a happy customer that has received their whatever they ordered. However, there are times when something in this process goes wrong, and then we have ourselves a very unhappy customer, and this unhappy customer will contact the retailer and ask where's their stuff, and this is totally legitimate. However, there are times where nothing in this process of delivering the package goes wrong, and you do indeed deliver the package to the customer, except this customer may have some nefarious intent. And then they later call in, and then they claim that they've never received, in this case, their box of chocolates. So this is not the only way we at Nordstrom would actually deny a claim if we figured out that some sort of fraud was going in that sort of manner. Other reasons why we would deny a claim would be that the package was eventually found, the customer had returned the items to the store for a refund, there was too much time that lapsed between the time the person actually purchased the item and then made the NPR claim, or the customer had already claimed a chargeback with their credit card company for that particular order. So in detecting what NPRs we should deny, at Nordstrom it started out as a manual process. Here we had a team who would investigate each NPR, and they would look for things like trying to understand why the package was not delivered. They would look to see if the customer had any previous fraud or NPR claims, and they would also investigate other things about the NPR itself. Because this was a manual process, you can imagine that the decisions made on whether or not to accept or deny the NPR was different depending on the person who was handling the claim. And in addition, because it's a manual process, it was prone to data entry errors. So our goals, when given this project, is we were concerned with speeding up the review process, as well as making the decisioning more consistent. And we wanted to increase the number of denied claims without increasing the insult. So what does that mean? So if we decide to deny someone and they were making a totally legit NPR claim, and then they got angry and went to the credit card companies and then placed a chargeback, that is what we would consider to be an insult. So in thinking about how to detect NPRs using machine learning, this is actually a fairly complicated problem. So it's complicated because in this case, it's an unsupervised problem. We have poorly labeled data, so we can't use data to train the model to it. And we're dealing with imbalanced classes. Most of the NPRs that we have are genuine NPRs and not nefarious. So some of the data that we brought into our model includes like customer details. Here we look at our customer history, things like how much they've spent with us in the past, how much they've returned in the past, Things like, have they ever had an NPR? Have they ever claimed an NPR in the past, or called their credit card company and then had a chargeback on any of our orders? In addition to that, we look at the order details specific to that NPR claim. So this would include the order amounts, the number of items in the order, etc. So we explored two different types of anomaly detection models. The two types that we explored were HDBScan and isolation forests. Both of these models can be used with unlabeled data, so it's an unsupervised, these are unsupervised models. They are commonly used in fraud detection. Both of them have the ability to detect outliers, and both of them have packages that are available in Python and R. The remainder of this talk will cover defining these two techniques, comparing the output of the two, and then talk you through hurdles in productionalizing each of these methods. So let's start with isolation forests. Isolation forests are similar to random forests, but the intent of them is to explicitly identify anomalies. So in this case, what I'm going to do, I'm going to provide an example, and on the right here is a made-up data set. And we basically have two features. So the first thing we want to do, is we want to select a point that we want to isolate. So in this case, we're going to try to isolate the star. Then we figure out what the min and max ranges are for our features. So we have feature 1 on the y-axis, feature 2 on the x-axis. Then we randomly select a feature. So in this case, my first randomly selected feature is F1. And then we pick some value that's within the min and max range of F1. And so in this case, the value that I picked was this, what is represented by this thin horizontal line. Then we notice that the point that we're trying to isolate is below this randomly selected value. And so now we relabel our maximum value as F1 max new. This is the randomly selected value that we had chosen. And so now the next step is to repeat steps 3 and 4 until the star is isolated. So when we do that, hello clicker. Hello clicker. Okay. Oh my goodness. That's exhausting. Anyway, so it took us 7 times to isolate this star. And so that 7 times is called an isolation number. So in this case, this star was kind of in a cluster of points. And we got a high isolation number. Now let's think about the same situation. Okay. Except that this time we're going to try to isolate an outlier. In this case, if we go through steps 3 and 4, it only took us 2 steps to isolate that outlier, right? So in general, what we have, outliers have fewer loops than the inliers. And so that's the basic concept behind isolation forests. So we use the isolation forest algorithm from the sklearn package. The parameters that you want to consider here are the contamination. The contamination basically adjusts the amount of outliers that the iForest will return. You also have the max features and max samples. This will determine how many features and samples each of the trees in the forest will use. And then N estimators is the number of trees. Thank you. Okay. So in looking at the outlier group, what we found was that all of the cases where the customer was involved with previous theft or fraud, or all the cases where they had a chargeback before the NPR claim, and most of the cases where a customer had a restriction, were included in this outlier group. So I'm going to show you an example, but there's a warning here. This is actually not real data. But it's an example of what the data kind of looks like in the outlier group. So, for example, this is a customer who has ordered from us all of 2 times. Their gross spend and their net spend are both $1,900. This means that they haven't returned anything. Their tenure with us is 6 days, and they have been flagged for previous fraud. So this is good because this isolation force is picking out these types of outliers. However, I'm going to introduce you to another outlier that it gave us. Okay, so this customer here has ordered from us about 200 times in a two-year time period. They spent a total gross spend of $48,000, about $48,000 in that time period. Their net spend, so they returned quite a bit, but their net spend was $28,000. They've been a customer with us for over 2 years, and they predominantly buy on their Nordstrom card. They've never had a history in our records of previous fraud or have been previously restricted at all. And so this is a really good customer. So if we want to go down the path of using an iForce model, we're going to have to figure out some sort of rules to kind of differentiate between the bad outliers and the good outliers. All right, so I'm going to go on to HDBScan. HDBScan is a hierarchical density clustering algorithm. And it's a 5-step procedure which is written up in these documents here. And I have to admit, I was crying when I was trying to figure out how to present this to you guys because this is actually fairly complex. And in fact, when you print out this documentation, the description of how it works is described in just 15 short pages. And at the end of this document, even the author says, it may seem somewhat complicated. So bear with me, okay? So I'm going to try to concisely describe to you HDBScan. Okay, first step, here we go. First step is, if you don't already have a distance metric or matrix, you compute a density matrix using the k-nearest neighbor algorithm. I'm not going to go into it too much more than that. Step 2, you build a minimum spanning tree. So this is an example of a minimum spanning tree. This is a theory that came from graph theory, an idea that came from graph theory. And here is an image where the dots here are your data, and those are the vertices. And then the lines here are your edges. And the edges connect each of those data points. And they're weighted by the density or the distance that was given in step 1. Then what HDBScan does is it takes a threshold value and then basically goes from your highest distance down to your lowest distance. And then the threshold, anything that is above the threshold, any of these edges that are above the edge of the, excuse me, that are above that threshold, then fall off. So for example, if you start your threshold at 0.8 and then lower to 0.72, the edges that would fall off would probably be these 2 yellow lines here. And so what HDBScan does is it just kind of goes through and changes this threshold from the highest value, distance value, down to the lowest distance value until all of the nodes have separated from each other, and it makes that record. How am I doing so far? Okay, next one. Okay, step 3. It takes that information and it builds a cluster hierarchy using agglomerative clustering. So in this type of technique, what it does is it starts with the leaves. It finds the leaves that are the closest leaves, and then it gloms them together into nice little clusters. And then it does that again, except with your nice little cluster. And again, and again, and again, and again, until you reach the top of the tree. And so now you have your nice cluster hierarchy. Okay, how are we doing so far? Pretty good? Okay, next step. Okay, so now it tries to condense the cluster tree that you produced in step 3. And so here it starts at the base of the tree, and it takes into consideration this concept of minimum cluster size. So this is a parameter that's specified by the user. And it starts at the top of your tree that you got in the last step. And then for each step down the tree, it figures out how many points fall off. And if the number of points fall off are greater than the minimum cluster size, HDBScan says, hooray, you made yourself a cluster. If it doesn't, it just takes the node. And then it continues down until it gets to the bottom, of the tree. Okay, next step. Oops. Okay, next step is it applies some nifty little algorithm to figure out which clusters to keep and return to the user. So here it just takes, and I'm not going to get too much into it, but it figures out the stability of the clusters and then returns them. Okay. Simple, right? Yeah. Well, actually using the model. So HDBScan is really kind of complex, but using the model is pretty simple. You really just have to kind of specify the metric to use. So it has some built-in metrics that you can use, like Euclidean distance and simple ones like that. Or you can hand it a pre-computed matrix of distances. And then you also have to specify the minimum cluster size. And that's it. All right, so let's actually get on to the real, what you guys came here for. Okay. Okay, so this figure on the left here, this is an image of our features that have been reduced down to only 2 dimensions using the TC method. Here you can see the clusters that the data produce, and the clusters themselves are colored as shown by this legend over to the left. And it also produces, and I'm sorry the colors aren't that great here, but this top one is labeled -1. That's our outlier population. And so the blue dots, some of them, some of the blue dots are outliers. Okay, so this model output, I should say what I put in here. Okay, so I have a minimum cluster size set at 20, and I use Gowers distance. I use Gowers distance because it allows you to use both binary and continuous data sets. And so because we have both data types, I use that distance. The model output 26 different clusters plus an outlier group. And I'm trying to figure out what the descriptions of each of these clusters are. And I do that by simply averaging all the features for each of the groups. So let's talk about the outliers. Similar to the iForest model, we have claims where the person had already made the chargeback, they had fraudulent histories, and they also had previous credit reversals in the outliers. Some of the top. Now let's talk about the clusters. This is the value add for this type of models. So the clusters, these were interesting. Here you had clusters of people that seem to have nefarious intent, possible nefarious intent. And I say that because we have clusters of people who had been flagged for previous fraud or theft and have been on the restricted list, and have also made chargebacks prior to placing the NPR claim. But we also had clusters of our really good customers. And so what was nice about HDBScan now is that you can segment out your good customers and your bad customers, and then use it to try to segment your populations. Okay. Okay, so one big factor in determining which model to use is the ease of deployment of the models. So I'm just going to go through the steps that are needed to productionalize both HDBScan and isolation forks. I'm going to start with HDBScan. So to productionalize HDBScan, you first have to collect your features. This is the ETL process. Then you have to calculate your distance matrix. And you have to create the clusters using HDBScan. And these two steps can be pretty slow. And not to mention that HDBScan is kind of a memory hog, so you're kind of limited as to how much data you can use for HDBScan. So you'll then have to take a sample of the data, just use your distance matrix, which then goes into HDBScan. And then you have to analyze the clusters. You have to know which clusters are the good clusters, and which clusters are bad clusters, in order to put this in production. And then if you used one of the in-house HDBScan distance metrics, you can then, thank you. Are you just pressing those slides? Whenever I do this, you're like, okay. Anyhow, so then if you have one of the in-house methods, you could then score with HDBScan's predict method. However, if you provide your own distance matrix, which is what I have done, you would have to find some other way to score your population. And so a possible other way is to just simply train a classifier to predict on the clusters that you predicted on, or using HDBScan. And then you would use that, then you would use that classifier to then score your population. So in most times, once you've already had your trained model, this would be fairly easy. You would do your ETL to get your features, and then you would proceed with the trained model to score your population. However, whenever you had to go back and retrain this model, which would be fairly often, you would have to go through this entire process again. And it's slow, parts of it could be manual, so it's a bit of a pain. Okay, so let's go on to the next step. So productionalizing the eye forest. So here we start off with generating the features, then we train the eye forest, and then we could just simply predict using the trained eye forest model. But remember, the eye forest model gives you outliers that are both good and bad. So you're going to need to apply some sort of filter to discern which are the good and bad outliers. But what's nice about the periodic retraining of the eye forest is that it's actually pretty simple. And so for our group, we chose this approach. Two reasons. One reason being the ease of deployment, is the second reason being that we were able to produce simple heuristics in this filter step that allowed us to execute on some of the business rules. Okay, final slide. I'm just gonna compare the two models here. So we have HDBScan, which uses a hierarchical clustering method, which limits the size of the data that you can use to train the model. iForest, on the other hand, can handle large amounts of high-dimensional data sets efficiently. HDBScan, you need to calculate a distance or a density matrix. iForest, distances are not needed, so that's nice. HDBScan, if you use a mixed data type, you're going to have to use a special distance. Binary and continuous data types are not a problem in iForest. iForest offers a predict method where HDBScan has a conditional predict method. iForest detects outliers and inliers, but HDBScan can actually figure out what groups can figure out groupings, so clusters. And then in productionalizing HDBScan, you would need additional steps to train the model, to train the model basically. And then the iForest, it's relatively simple to productionalize. From that, I just want to give credit to where it's due. So this is the team of data scientists that basically put together some of this work. From left to right, this is Christine Buckler, Nick Bucher, and myself. And other contributors here are Katie Winterbottom, who is my manager, and Stephen Rabbit and Chris Bowden of the loss prevention team at Nordstrom. And I also want to say that Nordstrom is hiring. If you want to continue your bid or start a data science career at Nordstrom, please contact me or go to this website. And I also want to say that there are people here that are also from Nordstrom that you could talk to. Anybody here from Nordstrom, please raise your hands. So feel free to contact any of us. Yeah, that's it. Any questions?
So, since you're talking about your team and how you deployed it, what was the work like to decide on it? And then once you decided on the isolation for us, how does your team operate at Nordstrom to make sure everyone's up to speed on how it works?
Woo!
If you can disclose that information.
Okay, so the first one was how did we decide between HDBScan?
No, I understood that was the topic of your talk. I was more asking did two of those people try did you all learn both of them together and decide together, or was it like a team focused on isolation forests? And because you mentioned it was 15 pages long and somebody had to learn it, and I imagine you didn't teach your whole team that you did eventually. So I'm just wondering how the team works.
Yeah. Yes. I'm curious about one factor. So the question was, how did we work together as a team to get this together, right? So we actually had an internal hackathon, which was a lot of fun. And so the three of us got together and pretty much shut ourselves out of contact for about 3 days. And then one of us worked on isolation for us. Christine worked on the isolation for us. And then I worked on the HDBScan. And then Nick here was the glue that held us all together. And so he was the one that was really on board trying to get us to communicate with each other more, because both Christine and I would get lost in the weeds, and he would just pull us back out and say, okay, where are we at? So he was kind of acting like the director of the group during the hackathon. So that's kind of how we operated in trying to look at these models at once. Does that answer your question?
Yeah, and the second part was just now, how will you tell your team, okay, come to my talk and learn how to do this, or do you have like several meetings where you teach your teammates how to use isolation forest? What does that look like at workshops?
That's a very good
Nice
question.
slides. You could use.
Oh, yeah. Somebody had pointed out that I needed to do an internal talk like this. That's probably gonna be what's gonna happen. Yeah. But quite honestly, I was just telling Erin had made an announcement before I came here, or before this talk, advertising this talk, but I'm way too shy for that sort of thing. And so I'm really glad that she did it.
Well, I think like a good follow-up to that is like, this is like the data science fraud team right now, so like, now how are we gonna use this in production?
Yep. That's me.
So like, how do we pass this off to, like, do we pass this off to engineers, and then they implement this, and like, who are stakeholders for this project?
Oh, yeah, no,
Like, expand on like, how we're actually production.
Yeah, so in productionalizing this, we took it in our own hands to productionalize the code this time around, but really we want to make it more robust. And so that's a focus area for future work.
Is there any concern of resourcing for that team that was supporting this manual process that you now expedited?
That's a very good question. I'm probably not the best person to answer that.
Well, I guess like saying it's are they excited? Are they like excited about this?
I'm not entirely sure. I do know that the idea is to get them working on other things. So I'm not entirely sure what that entails.
Would you run in tandem, you know, like you have the person and you also have the algorithms to see.
That is currently
the
how it's, yeah, it's currently how it's.
How long do you test your model before productionizing? In other words, how do you know when it is ready to go to production?
This is a very good question. So when we developed the eye forest, which is the one that we meant for, we did do some testing before we actually put it into production. And so that testing went 2 weeks. I can't remember how long it went. You remember?
I don't remember the number.
Yeah. Yeah, so it was about 2 weeks or so.
So is it more like the shadow traffic that you use for testing now? It's for production traffic?
I'm sorry, can you repeat the question?
What is the data you use for testing your models? Is it more like the shadow traffic that's coming?
I don't think I understand what you mean by shadow graphic.
It's a call center, so these are people actually physical on the phone with people, and so they would just have this in front of them when they make decisions. They'll get an automated kind of answer on what they should do. It's not like web traffic.
I'm glad you're keeping it.
So you decided for your team in the fraud detection that isolation forest was better and faster, but and the other one gave you good customers, and that could be something that marketing could use. And so do you like, when you have a solution like that, do you like cross with those other teams that it might help them? And have you thought about that? And to use that as opposed to the other?
That sounds like a very good idea. Perhaps I should do that. Yeah. That does sound like a good idea.
Is there a concern with respect to the retraining, where an outlier identified in an earlier iteration will no longer be considered an outlier when you're dealing directly with a customer, and you're talking about explaining that concept to a non-technical call center, how they would navigate that? Is that something that you can have to think about?
Well, I can't remember how this works, as far as the scoring goes. So I think that once it's scored, it keeps the same score. I'm not entirely sure though, so don't quote me on that.
But you give reason codes too, right?
We
So
do
like
give
in the call
reason
center, they can have an intuition for why they got the answer from the model.
Got it. I
And they
guess,
still make the choice, so they kind of reason between what they're looking at and then also the models.
yeah, I guess I'm thinking about if you would use like the new score to go back test and see if there was anything that got missed, but I don't know.
Good question.
Is there any additional feature engineering that you do for the iForest where you have some features where like a lower score is better, some features where a higher score is better? So you kind of like standardize everything where like high is good, low is bad to like kind of maximize that distance between features?
That is a very good question. We haven't gone down that route of optimizing the features yet.
Did you begin to look at if you want to divide it? So to be familiar with customers, your financial data, demographic data, to make sure that you're not optimized?
Yeah, so the question was, is the model biasing demographically? Is that
Yeah, just like how do you make sure that you're not optimized?
Yeah, so we tried very hard not to include any sort of demographic data. And so that is probably the biggest step towards not having some sort of demographic bias in it. Does that answer your question?
Yeah. How many features do you use?
The question was, how many features do I use? I have to go back and check. A lot. Quite a few. Yeah. Tens, probably like 40 maybe. Don't remember exactly the number, but it's up there. Up there being 40. It's up there.
You rejected supervised learning, I mean, concern about data set, right? But, and did you actually try it?
Oh, it's poorly labeled. That was the issue. Yeah. So we actually did use the labels in trying to train both the iForest and the HDBScan, but it was really very noisy.
I'm curious if it is already measured to or is expected to reach that goal of refusing more of these broad things, and how much work your team has to put into metrics and making sure their answer versus passing that work off.
So the question was, how did we measure?
Is it paying off, and did you have to figure out what it's going to, or did another team do that?
Oh my gosh, so it just went into production, so I can't tell you right now.
But like, are you going to do the follow-up, or is that like, or are we going to have to like, you sort of make a model and someone else did everything after that?
Aaron, what do you say?
It's a little bit of both, so
Yeah.
like Gina was saying, when we first launched it, we did this in a pilot way. And we kind of owned the side of that study and then the results. The longer term, when we do more continuous monitoring, we have a larger analytics board who we would then kind of send that over to build the reporting dashboards on the long view. So it's kind of a
Great. I'm just curious, given that, the holiday season, like the spiky shopping and Santa and all that, how did you address that? Is it a seasonality thing and then the model will adjust for it, or is it a matter of retraining it? It's gonna dramatically change.
Yeah, so I would imagine it probably would be retraining of the model. Since we just deployed it, it didn't need to be retrained anytime soon.
maybe soon.
But maybe soon.
Well, it's most likely using just data from last holiday or something like that. We're trying to more
But the dates gotta be one of your features.
Well, days between the NPR and the original.
So it doesn't know if it's Christmas or, June.
Yeah. So we don't actually use dates, we use time periods.
Does it, whether it's a gift or not, one of the features?
Not currently. And The gift idea is kind of hard to quantify it as well because we don't know the intent of the person who's purchasing the item, whether they're going to give it away.
But you do know if the transaction was done with a gift card.
That is true.
Which is also one of a big predictor because there's a lot of gift card fraud. So it's actually a phishing.
Yep, and we have features in there to detect if it was bought, if the NPR was bought with a gift card.
But actually, were there any exciting features that you were just like, whoa, that really did, yeah, that's gonna be a big predictor? Just you can tell us.
None that come to mind at the moment.
What about email addresses containing the word in it?
Oh, yeah. So we did a lot of work kind of parsing out email addresses and figuring out if they had Norn in the name or what else did we look at? The number of numbers in there. Like we looked at a whole bunch of different stuff in the email address. And that turned out to be pretty interesting. So yeah, that's a good point.
A lot of people have ignored in the email that are actually fraudsters because, well, that's one, or maybe they just want to look like big fans of the company and really, like, I wasn't scared. You look at me, I'm such a fan, I'm gonna know you.
We can be on our own domain, and my husband does it all the time.
You know, some people identify the techies and the.
Yeah, North from Red and Amazon Red. Yeah. Feel well at it.
How do you get data around the chargebacks and credit card companies?
That's
it.
That is a good question. Erin, do you know off the top of your head where that data comes from? Yeah.
Oh, we get it from our credit card.
Is it only Nordstrom credit cards that we see the chargebacks from?
I don't know, that's a good question, actually.
Yeah, I can't answer that. I'm sorry. Yeah, I'm not entirely sure. Yeah. Good question there.
So when you say this has been productionized, is this essentially going into that system that's used by people operating the telephone essentially, and they get like this feedback on whether it's actually fraud or not?
Yep.
So in this case, when you're identifying anomalies and you're suggesting that this is potentially fraudulent, did you happen to test out the results that you're putting out with people who are possibly taking those calls to see if their intuition kind of aligns with it? Because like a lot of the times, even more recently, this happened with Apple, where people were like, "Oh yeah, algorithms did it with respect to the credit score and assigning credit limits and stuff." So they usually just hand it off to an algorithm, which people don't really understand, and that leads to, in your case, mentioning what was insult, essentially. Right? So, was there any kind of measurement on how exactly that was go about it?
Yeah, we did do some A/B testing before we actually put the model, and some of that work went into figuring out how well our model was doing compared to what the call center was doing.
And how closely aligned?
They were very closely aligned, actually. In fact, they were almost, identical?
You did it also earlier than that, looking at the clusters and then layering on from historical data the decisions that were made and validating that the things that you were flagging as kind of outlying were pretty consistent with what they denied, giving us some feeling that it was going to work pretty well.
Yep.
Maybe be fair, because I have a sticky question that the labeled data, as we will call it, I would think the labeled data would be using the call center results as well, even labeled fraud, not fraud.
Yep. But remember I said at the beginning of the talk that the decisioning was a manual process, and that the decisioning differed depending, decisioning could differ depending on the person who blew it. So it wasn't taken in a consistent way.
And Nordstrom's a nice company.
Yeah.
So by and large, we accommodate the claims, so there's a way more fraud that is accommodated than the other way around. So it's a really inconsistent label.
But then wouldn't that also come out when you're testing your algorithm with the call center, that you're saying the results are very similar, but I would think the algorithm would say fraud more often than the call center would say fraud if they have to be nice. Unless your algorithm is too tough to be really nice.
It's too neat.
I see. I think that's really nice.
We will agree when something's fraud, and I think is what you're saying, like, if it's so extreme that the people at Nordstrom actually call it out as fraud, and they're obviously fraud, and where it's a little more difficult, there's a gray area where it's not clear immediately that this is a fraudulent call, and so usually it will be accommodated, so that's the whole thing that's really hard to keep apart.
I think the other part too, is not like, it's hard for us to sell an algorithm to our stakeholders if it doesn't agree with what they're already seeing. So this is kind of like a sanity check, like, all right, like, look, we can use this.
Hopefully.
How did you get you talked about scoring, how did you get a score for an unsupervised algorithm? Maybe that's just something I don't know, but.
So HDBScan, in general, like a hierarchical clustering algorithm, you don't score with it, but HDBScan has done some magic and offers a predictor method, and that's how you can score. The other way for HDBScan would be to train a classifier that predicts on the clusters that you've created with HDBScan, and then use that to score the population.
And that's what you did with the isolation.
That's what I did with HDBScan. Isolation forest, though, it offers a predict method. Yeah. Good question. Any other questions? I'm so thrilled for the. The questions that you guys asked were amazing, so thank you very much. I really appreciate it.
Just want to say thank you so much again to our hosts and our speakers. This was a really, really fun night and a really great discussion. Thank you. Oh,
Feel free to take some food. Thank you.
Oh,